Let's read our next word problem. Alfredo wants to rent a truck to move to Florida. He has determined that the cheapest rental rates for a truck of the correct size are from a local company that will charge him $25 per day and 20 cents per mile. He has not yet completed an estimate of the mileage of the trip, but knows he will need the truck for 3 days. He has allowed $350 in his moving budget for the truck. How far can he travel for a rental cost of exactly $350? Now that we've read our problem, let's look and see what facts we've gathered. First of all, we know that the total cost for renting the truck will be the per day cost plus the mileage cost. We know that at this particular location, the cost per day is $25 and the mileage was 20 cents per mile. Now we want to find out how many miles $350 will pay for. One additional fact, if you'll recall, Alfredo knows that he needs the truck for a total of 3 days, so that's already known. We'll write it here, 3-day rental. Now, he has $350. That's all the money he's budgeted for his move. Let's write a little equation. We know our total cost, we'll represent that by TC. His total cost is equal to his per day cost, which in this case is $25 per day, times the number of days, which he knows is 3 days, plus the mileage cost. Well, let's think. He knows it's costing him 20 cents per mile, but how many miles is he traveling? That's our unknown variable. So we'll let X represent the number of miles that Alfredo has to travel. So we'll let X here represent the number of miles for his trip. Now, total cost is really also known. Alfredo knows he only has $350. So if this is a known fact, 350, and this is a known fact, we know it's costing him $25 per day at 3 days, that's $75, plus the only variable that's left in our equation is X, which represents the total number of miles he could travel on a 3-day rental at $25 a day and 20 cents a mile when he has $350 to spend. So let's write that down, 0.20x. So we're almost there. All we have to do is solve this equation for X, subtract 75 from both sides. That gives me 275 is equal to, on the right-hand side, we're left with 0.20x. Divide both sides of this equation by 0.20, and on the right-hand side, we'll get x. On the left-hand side, 275 divided by 0.20 is 1375. Now, what does that mean? We were asked to find out how many miles $350 will pay for at a per day cost of $25, a mile cost of 20 cents per mile. So we found out that he can travel 1,375 miles. Hopefully his trip is less than this, so then he'll have enough in his moving budget to pay for the move. Let's look at our next word problem. Ginger has 5 more quarters than dimes. She has $5.10 in change. If she has only quarters and dimes, how many coins of each type does she have? Now that we've read our problem, let's begin to solve it. Now remember, the main fact is that Ginger has 5 more quarters than dimes. Let's write that down. 5 more quarters than dimes. So, if she has 5 more quarters than dimes, which does she have more of? Quarters or dimes? You got that? She has 5 more quarters than dimes. What does she have more of? She has more quarters. So since she has more quarters, we're going to start with the smaller variable, dimes, and let that be our x. Now, just to get away from always using x to represent the number, let's be a little more creative, and since we need a variable to represent the number of dimes, how about if we choose the variable d? So let's let d equal the number of dimes. Now, the relationship between the number of dimes and quarters is in the statement. She has 5 more quarters than she has dimes. So if we take the number of dimes d and add 5 more, that should give us the total number of quarters she has. So let's let d plus 5 represent the number of quarters. Now, there are a couple of other facts here that we need to discuss before we can go on. First of all, remember that she has a total of $5.10 worth of change in her purse. So we'll write that down. $5.10, that's the total amount of money. And remember, all of this change is in quarters and in dimes. Now, you might be tempted to say, well, the number of dimes plus the number of quarters, or d plus 5, is equal to $5.10. But think about that. What are you saying? D represents the number of dimes, not how much the dimes are worth. Now, we all know that a dime is worth 10 cents. So number of dimes, we're right here at 10 cents each, and the number of quarters at 25 cents each. Now, I'm sure you know that if you were to have, for instance, 5 dimes in your pocket, you would take the number 5, multiply it by 10 cents to get 50 cents. So the number of dimes times the value of the dime will give you how much money you have. In her case, she has d dimes at 10 cents each, so write that as 0.10 times the number of dimes. Now we're talking value of the money she has in her pocket, plus each of these quarters, remember she has d plus 5 quarters, is worth 25 cents. So we'll write 0.25 times the number of quarters, which is d plus 5. Now what do we have written thus far? We have 10 cents for each dime she has, 25 cents times each quarter she has. That will give us the value of all the change in her pocket. In this case, that was a total of $5.10. So we'll write that down here. I'm sure you're getting to the point where once you get that equation written, you're home free. The rest of it's just to use your algebra skills and solve the equation, in this case, for D. Let's do it. We have 0.10D plus, again, we're going to use our distributive property, 0.25D plus 0.25 times 5 gives us 1.25, and that's equal to $5.10. Again, I hope you recognize the distributive property there. The rest of it is to collect like terms. So this gives me 0.10D plus 0.25D, which gives me 0.35D plus 1.25, and that's equal to $5.10. Again, this is a result of adding 0.10 plus 0.25D. Then we're ready to subtract both sides of our equation by 1.25. So we get 0.35D on the left-hand side, and we subtract $1.25 from both sides. We're left with $3.85, or 3.85. Again, that calculation, 510 minus the $1.25 from the left-hand side of the equation. We're almost there. I'll write this out as a division. We're going to divide both sides by 0.35. When we do, I hope you see that D is equal to, on the right-hand side, we have the calculation 3.85 divided by 0.35, or that's equal to 11. You can either use a calculator if your teacher allows you, or go ahead and perform the long division on your own. Now, don't be so anxious and say D equals 11, I'm done, let's go to the next problem, because we have to answer the question asked. How many dimes and how many quarters did she have? Well, in this case, we can see the number of dimes is 11, and the number of quarters is 11 plus 5, or in this case, that's 16. So we can end our problem here by saying she had 11 dimes in her purse and 16 quarters, and I will leave it up to you to go ahead and check to make sure that's correct by taking the number of dimes 11, multiplying it by 10 cents each, take the number of quarters 16, multiply it by 25 cents each, and at the end make sure you get a total of $5.10.